the uh, hands-on. Okay, so my screen is visible.
Yes.
Okay, so let's start with the neural networks. So it was in early 1940s it started recognized, and in earlier days it the idea was it mimics the brain working of a brain. So our brain consists of a set of neurons, okay, and these neurons are connected to each other. So millions of neurons are there in our brain, and these neurons passes information. And now understanding the complexity of the brain, so we just want to mimic it to our uh, we just want to mimic the complexity to by the machine. So we want, and as a brain learns, for example, uh, there's a kid, suppose a 3-year-old child, and you show him 5 cat pictures and 5 dog pictures, and you say like this is a cat and this is a dog. Okay, so cat looks like this, it has this kind of features, and this is a dog, it looks like this. So how does 5-year-old kid remembers this? So because by seeing so many cats, by seeing so many dogs, he is able to recognize which one is cat and which one is dog. That was the idea behind neural networks. That exactly same thing we want to in the brain. Actually, what do a traditional machine do? So if you see a traditional machine, which is a calculator, example is a calculator, suppose. So you just give 2 numbers and it gives you output. That's the only thing it does, right? But machine learning, AI automated machine, what it does is you don't give a plus b and it simply gives output. It learns on the past input, and it learns on the information and gives some output which may or may not be correct. While if you see a simple calculator or a simple computer, you give instructions and it gives you output which is always correct. Okay, so in neural networks, that is not the case. You just have some information, some data, previous data, and what you want to do is you just want to uh, know, based on the previous information or knowledge that you have learned, you want to know the output of the new test case that is there in the front of you in the real world. If you see some image, so you can be able to predict whether it's a cat image or whether it's a dog image, given you have already seen how cat, you already know how cat looks like and how dog looks like. So I hope the idea is clear. So this is the idea behind uh, neural network. So this is the architecture of a single neuron. So here all the processing is done, all the calculations, and this takes the input from the user and transfers it to, inputs are also coming from here and transferred from these dendrites. Okay, so and this whole axon, that is the length, is the uh, basically some weight is given. So idea, I will show you the resemblance with the actual neural network. Here you have a node, and then you millions of neurons are interconnected in our brain from these dendrites and from these axons. Okay, so good connections allowing large signal slides. So this depends upon how much, for example, suppose you touch a hot plate. So signal travels at a very fast speed, right? Signal travels at a very fast speed to your brain that you have to remove your hand and it comes back as a reflex and you remove your hand from the plate. So the intensity of the signal Okay, that is the weight intensity of the uh, this basically uh, signal that is transferring is uh, decided by the event that you are facing, right? So that exactly same thing is with the neural networks. So exactly similar thing happens with the neural network. So as you can see in the diagram, so one neuron is like processing unit in the brain, which is node over here, and then you have weights, and these weights and the output processing is done in the neuron. Then you have input, like input was maybe you have touched a hot plate in a real world, so that is your input, right? And weight is the signal strength, so a signal strength should be higher, right? And what is a neuron? Neuron is, it's calculating the weight of it's basically doing the processing, and it will give higher processing value to the next neuron if depending upon the kind of output or it's learning account kind of problem it's facing. Okay, so I hope the basic ANN is clear from here. Now, many simple neuron like threshold switching units, many ways interconnections among units, highly parallel distributed processing, learning by tuning the connection weights. Basically, what do we want to do is we want to do the processing over here and learn these weights. All these W's we need to learn. And how do we do that? We do tuning, parameter tuning. Okay, so parameters are nothing, these are the weights and biases, these are the parameters, and we do tuning. Now, input is a high dimensional discrete. Now, there are many problem domains. Like first is the input is a discrete value. Input can be discrete value or the real value. Output can be discrete or real value. Okay. Yes. Someone wants to ask something. Output can be a vector of values, form of target function. What kind of target function? And then it's a black box model. Black box means I just give as input cat or dog, and you tell me whether yes or no, whether it's a cat or whether it's a dog, yes or no. Okay. I don't want the intermediate calculations. I don't want to know the intermediate calculations. Okay. So, example of a neural network model is shown over here. So, input is the age, gender, and state. So many inputs are given, and what is the probability that person is alive? Okay, so if it's suppose 100, age is 100, and its gender is some male or female. One is male and two is female, and in which stage that person is. So many things are there. Okay, so what is the probability that person is alive? Now this is a simple neural network that is shown in the figure. If you see over here, 34, 2, and 4. This is a one training example, one training sample where there was person number 1 or his name was some X, and that person X has three input features. His age was 34, his gender was male, and then his stage was 4, and so many other features can be there. So these are all features. Okay, and then point 0.6, point 0.2, point 0.1, point 0.3, point 0.7, and point 0.2. These are all the weights of the connection with the input, input with the neuron. This is also one node. This is also one node. So there are two nodes. Okay, and these nodes do the processing. And when you multiply x with this, and then you multiply x with this, then x with this, x with this, and this 4 with point 0.7, 4 with point 0.2, you will get some value, and then you add all these. When you add it, this is summation signal. You add this. Actually, what it will add is, if you write it like this, it would be somewhat 34 multiplied by zero point 0.6 plus, uh, if you add calculation for this neuron, I'm telling first neuron, this one, and this one. Three connections are there. You have to make all the connections to all the neurons in the previous layer. Okay, so 34 multiplied by zero point 0.6 plus 2 multiplied by zero point 0.1 plus 4 multiplied by zero point 0.7. So that would be the summation value after summation, right? Then what do is you apply some function, which is a sigmoid function. Suppose this value was 1000. You don't want value between 1000, right? So what you do is you apply some function. This is a sigmoid function. What does it do is, I will tell you later on how the sigmoid function works. So that's very interesting concept. So sigmoid function reduces the range between 0 to 1. It was earlier, suppose after summation you get some value like 35. So it reduces its value to 0 point something. Okay, so this is a sigmoid function. Now, what suppose it reduces it to 0 0.5. Now, while going to the next layer, it 0 0.5 would be multiplied by the weight of this plus the value that is calculated over here by summation of these three, then sigmoid, then you will get suppose 0 0.6. So 0 0.6 multiplied by 8 plus 0 0.5 multiplied by 0 0.5, and then you add it, summation again, and then again you applied sigmoid. So at every layer there are two things. First is summation, sorry, at every node two processing things are done. First is summation, and second is the objective function. This objective function can be sigmoid, tanh, ReLU. There are many objective functions. And then this is how the value final probability is calculated. Now, why are we doing so many calculations? What is the need of this calculation? The need of this calculation is, suppose you have a boundary like this, points are like this, plus over here and zeros over here. This is called a non-linear boundary. So for non-linear boundary, this is a polynomial function, right? So if you multiply this one, x1 into x2, so this is also a polynomial function. If you see, x1 w1 plus x2 w2 plus x3 w3 plus x1 this one and so on, and then plus, so if you multiply so much and then you apply sigmoid and then you again multiply that x1 w1 with this w2, right? If you multiply it with this, you will get a polynomial function. Okay, so any kind of polynomial function, non-linear function, etc., everything can be, you know, formulated using this kind of neural network. So neural network are very efficient because they can separate the data points into non-linear boundaries. I hope whatever I am telling, everything is clear. So I wanted to make this to be interactive session. So uh, uh, please let me know if it's clear.
Yes, it's good.
Okay. So can anyone of you tell me like why we are using neural networks? What is the advantage of using neural network? It can separate out points with a non-linear decision boundary, like maybe polynomial function or something like that, right? Okay, you can ask me if you have any questions regarding this. Then we can move on. Now, before we move on, I will show you I will show you one thing that you must always do. For example, okay, I am inserting a table. You can see to make things easier. Now, what is the input in the neural network? Input is the values of x1, x2, okay, x3. So in this neural network, there are three x's: x1, x2, and x3. Okay. Uh, this is also called as features. X1, x2, and x3. Right. This is also called as feature, and output is y. Y means whether it's alive or not. So if I write it as 0, that means not alive. 1 means alive. 0 means alive. 1 means not alive. Okay. This is my first training example, which is 34, 2, and 4. The value was 32, 34, 2, and 4. This is my first training example. This is called as a training example, training sample, or training example. Which one? This whole. Okay. Okay, this is one training example having three features and one class label. This is also called as class label. This is also called as feature 1. Feature 1. This is feature 2. This is feature 3. I hope this is clear. Okay. Now, if I say feature 1, so I will count this. This whole is the feature 1. If I put it some values, 40, age was 40. Feature 2 value was 3, 4, something like that. This was suppose 100. And this was 3. This was 1. Something like that. Okay, so this was my data set. This is the first training example. This is second training example. This is third training example. And this is first feature. Every column is one feature. And this column is a class label which we want to get as output. So I'm telling you these terms because I'm going to use this a lot. Okay. Now this is a sample example of a data set. This whole is a data set. Now let's go back to our model. These are all independent variables. Independent variables I will call as independent variables or features or inputs. Everything is the same. Okay. So this is features. Okay. Then weights. These are all weights. Value of uh, synapses basically each and every. Then this is the hidden layer. User don't know about this layer, so that's why it's hidden. So user only know input and only know output. So I give as input to this value as input to the model, and output this value uh, will be calculated, and I will also tell that actual value. So actual value was 1, model is calculating this, so I will call it as y hat, y predicted, and actual y. Okay, so this is predicted y and this is actual y. So actual y was 1 and the model has calculated 0.6. Okay, so the difference between the actual one is predicted is called the error. Okay, now then you have dependent variable. Dependent variable is also called the class y, class label or y. Okay, let's start. So at every node the sum of all the inputs plus this plus w naught. So this is the additional initial value which is also called bias, that is added. Okay, actually the equation is uh, for n variables you do w1 x1 w2 x2 plus w3 x3 plus w1 xn plus x naught w naught, and value of x naught is taken as 1 and w naught is nothing, it's just bias. Basically I will, if I say uh, w naught x naught is taken as 1 and w naught is called the bias. In some places you will see as b. So this equation in some places you would be written as uh, b plus wixi, and where x is from 1 to n. So 1 to n are features, so n features are there or n dimensions are there because n columns are there for the data set, right? So for n columns, n dimensions or n features, everything is the same: feature, dimension, column. Okay, input is a bias, and the bias, a additional term is a bias, which is where x naught is 1. Okay, I can write this as w naught x naught, where x naught is 1, or I can write this as bias b. Okay, so this is how sum is calculated. Then after summation, sigmoid function is applied or any other objective function can be applied, and then the value is calculated for that node. So this whole processing is one unit, one node. So for one node, this much processing is done. Okay, this is also called a perceptron model. There is only one node. Okay, so there is one node. Now, example is shown over here. Fx, this is sigmoid function. So sigmoid function input, you can see any value. Input is 0, 1, 2, 3, 4, 5, 6, 7, any value, and output is always between 0 and 1. So y value is always between 0 and 1. So it scales the value. Suppose input was 1000. So it scales it to 0 and 1. Okay. So scaling is done. Next is this is one example of a neural network. Now, how do we calculate W1? How do we calculate W2? And how do we calculate W3? And how do we calculate? There's one more W0, but for simplicity, I have not written it. This is also called bias. We have seen it. Okay. Now, uh, so how do we calculate these weights? So initially, this is very important point. You have to remember it, that in neural networks we always gives weights as random numbers as input. We do not give zeros as initial weights. We always give some random values as initial weights to while training the neural network. So we give some random value 5, 6, 7 to this, and then we keep on training it, and adjusting the weights such that our error is reduced. Whatever y it is predicting, it is same or approximately equal to y. So the problem is clear. What do we want to do? Yes, any doubts? What do we want to do is we want to find out weights, those weights in such a way that the error is reduced. Okay, we want to adjust the weights. We want to find out the new weights such that our error is less. Okay, now suppose initially randomly we have given these values w1, w2, w3. So the x is calculated as this. Plus there is bias also. I have not written it. You can assume this is there. For simplicity, I have not written it. So x was calculated as 21.34. Now 21.34 is put over here and fx is calculated. So for 21.34, you apply the subjective function of sigmoid in this fx only, and you will get some value between 0 and 1, right? So you will get some value, let's say 0.1 or something like that. Okay. So first, this is for first training example. You keep on repeating it for first data point, second point, third point, and for all the points in your data set. Okay. You keep on doing it, you keep on training. So you initialize it random weights. So this is example, first training example, and you initialize with random weights, and then you calculate some value. You get, let's say, 0.8. So what is your error? Error is 0.8 minus 0. Okay, so error is 0.8. Now what you do is you back propagate. You want to back propagate, you want to reduce error by changing the weights. Of course, you cannot change this value. You cannot change x, you cannot change this, and you cannot change this. What you can change is you can change these weights. So you back propagate and you change these weights. You adjust these weights. Okay. You can you can see that when going left to right, you are multiplying the weights. So while going right to left, this is called forward propagation, and going right to left is called backward propagation. So while going left to right, you multiply, and while going right to left, you divide. Okay, you divide these weights by some value, and what is that value we will see later on. You divide these weights and you change those weights, and then weight 1 is changed to some new value, and then you keep on multiplying it this whole again. Suppose after multiplication you get some value 0.6, so new error would be 0.6 minus 0, and you keep on repeating this process, this and that, forward and backward. For all the training example, you keep on doing this. Okay, this is how a neural network is trained. Similarly, for second, what you will do, you will calculate and then find out the error. Repeat this thousands and maybe millions of times, and making slight weight adjustments. Okay, so then you keep on adjusting weights, you keep on repeating this process until for all the training examples you don't get some minimal error. Okay, minimal error means this is a function, right? This is a polynomial function, so this point is a minimal. So you intend to reach to this point. Okay, so you need to at every by every time learning, you need to reach to lowest point. This was an example of single layer, only one hidden layer is there. In this you have 4 hidden layers. So first, then you need to forward propagate, multiply these over here, apply objective function, then go to next layer, then go to next layer, then go to next layer, and keep on doing so. Finally get the error, then back propagate, and then repeat the process. Okay, so this is how a neural network is trained. Okay, now decision boundary. So I was talking about decision boundary. So neural networks are very good. Suppose you have only one hidden layer. So this is one hidden layer. This is input layer, this is output layer, and this is hidden layer. So if you have only one input layer, you can make somewhat like this decision boundary. Now if you keep on adding these hidden layers, you add 2 layers. So decision boundary can be like this. Okay, so many combinations of convex regions can be found if you add more and more number of neurons in this. Okay, so multi-class. So similarly, uh, this was all about decision boundary and the neural network working. How does it work? So I hope this is clear to all of you. Any doubts? I'm trying to make this as simple as possible. Usually this involves a lot of maths, but I'm not getting into much maths. But if you want to learn the maths behind it, Definitely you can do so, and I'll be happy to help you all. And on my YouTube channel also, the videos about this are available, and maths, all the maths is explained over there as well. So I'm just telling you the basics, and then we will move on to hands on. Okay, so this is for the, so I have shown this example for the single output where you are classifying as 0 or 1. Now suppose you want to classify, you have three outputs, let's say good, average, bad. Okay, so three outputs. So multi-class output. So for this, you output the probability. You will say, okay, if probability is near to 0, I will say it belongs to class 1. If it's near to 1, I will say it belongs to class uh, 3. And if it's between, let's say, 0.4 to 0.6, I will say that it belongs to class 2. So that's a multi-class output. Okay, it's nothing. Only the class labels are different. That's not between 0 and 1. They are just some probability values. Okay, so that's a difference. Now you have to, for a basic neural network, you what you have to do is you have to set up number of hidden layers, decide number of hidden layers, and number of neurons or nodes in the hidden layer, type of activation function like softmax function, ReLU, or any other objective function, and then what kind of objective function and activation function. Basically, objective function is, sorry, I'm talking about activation function, which is ReLU and TANH and etc. Objective function is what you want to minimize. For example, in a linear regression, you minimize sum square loss, y minus y square, square sum square loss. So what kind of error or objective function that you want to minimize? Okay, minimize means you want to reduce the error. So what kind of function you want to use for the minimization? Okay, there can be many types of minimization functions or objective functions. Like one is logistic function, second is sum square. Generally we use sum square. Okay, uh, then you have, so this is the activation functions. Now input is xi, this is the input. Hidden layer is, it, what hidden layer will do, it will multiply all the inputs with the weights. Okay, and then it will multiply it, and then what it will do is, what this hidden layer will do is apply sigmoid. So whatever edge is coming over here, it applies sigmoid and reduce the range between 0 to 1. Then what it will do is, whatever it outputs, suppose it outputs some value 0.5, so 0.5 is again multiplied by y with the weights. So over here, so this is again linear multiplication simply, and then sigmoid is applied again over at this layer. So sum is done, and then sigmoid is applied. So this is sum and then sigmoid, and then j is the loss. So this is sum square. You can see y minus y predicted. Predicted y is a y that you get by solving this, and actual y is a y. So difference between these two is the error, which is the loss. You can also call it as loss or error, anything is okay. So loss, and sum square means sum of square error, error square of error, right? Difference between actual and predicted square, and then sum. Okay, so this is the loss. So this is how our neural networks work. Now I will discuss three activation functions. First is the logistic. So this is a formula, 1 upon 1 plus e to the power minus u. So generally we use sigmoid function. Whenever you don't know which one to use sigmoid. It works well. But in some cases, tanh function is another activation function. It is really good, and it's better than sigmoid. But the problem in the tanh is, it shifts the range from -1 to +1. The range of this is 0 to 1. Sigmoid is 0 to 1. So sigmoid is somewhere here. If you so this one. So this is sigmoid, and this is tanh. So sigmoid is between 0 and 1. So 0 and 1, while tanh is between -1 and 1. So range of tanh is somewhat bigger. But for whenever you don't want negative values, use sigmoid, and when negative values is fine, use tan h. Okay, tan h works better than sigmoid, but depends on the case again. Now ReLU is very highly implemented when you have a linear network. You have suppose 1,000 hidden layers or 100 hidden layers. So when you have a lengthy network, use ReLU. ReLU is really good. This is the formula for ReLU. So after zero, uh, whatever the function of z, it makes it as it is. So if you have 1,000, so if your function is outputting 1,000, suppose this value was 1,000, so output would be 1,000 only. Okay, and whatever is the negative value, it makes it to zero. Okay, then you have, this is leaky ReLU. Leaky ReLU is also the modification of ReLU. So ReLU is very popular in deep learning, where you use networks like it you know you it is used in the things like LSTMs and GRUs, where you have basically it helps in reducing vanishing gradient. I'm not getting into the details of that, what is vanishing gradient, but when you have a deeper network, in that case, use ReLU. So ReLU is very much used. So it's very good activation function. Now there are backward propagation. Now I'll tell you backward propagation. So in forward propagation, you have sum square loss, and you can also use cross entropy. So this is log loss, logistic loss, and this is the backward propagation formula. I will tell you what how backward propagation works. Now actually what do we want to do is, given a training data set, xi is the features, and xi can be many, like many features, and then yi, and then xi can range from 1 to m, like many columns can be there. You need to find out if with a theta somewhere, weights are also written as theta. So weights and theta, w or theta, one and the same thing, both represent the parameter. So weights and bias. So if someone asks you what is the parameter of a neural network, you will say weights and biases, or theta and bias. Okay, now loss function, you need to find out which, you need to select a loss function, maybe log loss or some square loss. Then define the goal. What do you want to minimize? Like, what do you want to minimize means, you actually want to update your weights or theta, such that this whole function gets minimized, right? And then you, how you minimize this, you use gradient descent, stochastic gradient descent. Now what is gradient descent? Gradient descent is one of the many algorithms that you can use to optimize a function. Now optimization is not is not a small topic, and if you want to get into optimization, and you want to know what a gradient descent, what a stochastic gradient descent, let's we can discuss this further in some another class. But it itself is a lengthy topic, so I'm not getting into the details of that. So let's this is the only formula you have to remember. So weights at time t plus 1 is equals to weights minus, this is the learning rate, and this is the loss, basically gradient. So I told you, like, while going left to right, you have forward propagation, and while going right to left, you have backward propagation. So you divide. So this value is the basically derivative, divide division of loss of with respect to theta. So loss was at the output, loss of actual versus output with respect to the original parameters, input parameters. So output with respect to parameters. So this is nothing, this is just the division of this with respect to this. Okay, so in the back propagation, what do is you just back propagate from here to here, then here to here, right? So it's a chain rule. You backpropagate from here to here, from here to here, from here to here. So you want to calculate derivative of y1 with respect to node at here, then derivative of this with respect to node over here, then derivative of this with respect to node over here. So basically you need to divide. So that is what a backpropagation is. And what, why you want to do it, you want to find out a new theta or new weights, right? So that's what back propagation, that's how back propagation works. Basically you differentiate all your losses with respect to inputs. Now I think this is the whole lot of maths. Let's skip this part, and I'm just going to move on to uh, uh, so this is the final applications. So there are many applications of neural network: signature recognition, stock market prediction, and so many other. And then these are some metrics. Let's move on to lab assignment. Now, if you all are having collab with you, you all can do the lab assignment with me. So I can explain you how to do it. If you don't want to do it, let me know. Like I will do and I will explain to you. So anything is okay. If you want to do it, I can tell you how to do it, and you can keep doing it with me. So let me know what you guys are suggesting. So you want to do the lab assignment parallelly with me?
Yes, that would be better, I think.
Okay, sure. So please guys open up Google Colab. I hope you have worked on Google Colab. Let me know when you guys are done. So today's lab assignment is, I will explain the problem to you. So the problem is, suppose you have set of codes. Let me show you example of some codes. Now, I have written some codes like, so what we want to do today is we want to classify the text as motivational quote or demotivational quote. So the problem for today is, assignment is classify the text as motivational or demotivational quote. Okay. Now note down these sentences. I can paste these sentences in the chat box as well. You can. Okay, I'm not able to.
Hi, Apeksha. The chat box is disabled. Disabled
Uh-huh.
from the organization.
Okay, okay, no worries. So what we can do is, you people can note these sentences. Okay. Now you can see first sentence is a motivational quote. So this is a motivational quote. this is a demotivational quote. Be lazy and win the life. So this is a demotivational. Life is short. This is demotivational. Be lazy is demotivational. Don't be lazy because life is short. Uh, this is motivational. Don't be lazy and don't be lazy to win. Now, what do we want to do is we want to use neural networks to classify whether it's a sorry. Just give me a second. Okay. So the problem is clear. I think problem is clear to you. You can take the uh, snapshot of these sentences and then write it on your own. So this is only 6 sentences. What you have to do is you have to write such 20 similar sentences and create a data set. So this is our data set. Okay, now let's start with assignment. So first of all, what you want to do is create a data set of 20 lines of text for the class 1 and 20 lines of text per class and store them in a text file. Okay, this is your first step. You can take snapshot of this PPT. Okay, then what you can do is you have to generate a frequency matrix. Now, what is a frequency matrix? So this is a frequency matrix where you have all the possible words: be, win, work hard, lazy, life, in all the sentences. Not in the first sentence only. In all the sentences, you will have all the words, and then you have zeros and ones. So you is there? No. Will is there? You can see these are the stop words. You will, if. What is a stop word? Stop word means the word that is not important in classification. So you, I, me, in, and, the, t, a, o. So single letter words or these words are stop words. So whenever you are cleaning the data set, first of all, you need to clean the data set. You need to remove such words which will not classify as motivational or demotivational. Okay, remove such words. So you will win. So you is you will. These two are stop words, so you will are removed. When is there? So when is there in the first sentence? If is removed, you is again removed. Then work hard is there, so work hard, right? So whenever that word is present in the sentence, so in the first sentence only three words were present. In the second word, be was the be is present, lazy is present, and is a stop word and it is removed, and win is present over here, lazy was present, and these the stop word and life is present. Okay, so this is clear, this matrix is clear. So what you have to do is you have to create a data set of 20 lines and then you have to convert it into the matrix. Now you have got the features. So this is first feature, second feature, third, fourth, fifth, sixth. Six features as input and output is 0 and 1, motivational and demotivational. Okay, now you can train the neural network simply. Now this is your assignment. I hope the assignment is clear to you guys and I will show you the code for this. Now I have imported, I have clicked. So first of all, what you have to do is you have to click on the table of contents and then you have to click on the folder over here. You have to click on upload. Okay, and when you click on upload, you can upload your file. I have uploaded this assignment 4.txt file over here, right? And then you have to start working on it. So start working on it and let me know how start working on it along with me. So any one of you who's working can share your screen or can ask questions. Okay, I will explain the assignment first, and then you guys can start working on it and let me know if you face any difficulty. So I've imported pandas and numpy, and I have read the sentences into the sentences.txt. pd pandas.read csv. I have read the file, text file, and if I print the data over here, if I write the data again and I execute this one, what I will get is I will get 6 sentences. You will win if you work hard, be lazy, life is short, be lazy, don't be lazy to win, and so on. Okay, 6 sentences. Now I can print the data dot shape. Shape of the data is 6 rows and 1 column. What I want to do is I want to divide it into multiple columns and I want to remove the stopwords out of it. Right. So first of all, what I will do is I have converted it into array. Actually, this was a list, right? So if I print it now, so this list, my list is converted into an array. Okay. Now NLTK is natural language processing toolkit. What it does is this basically remove the punctuation. Like you, if be, these words are the punctuation symbols. To remove these, what you do is you download the punctuation. Okay, if you print this punctuation, it will give you a lot of words, and already built in, you can download the whole dictionary. Okay, whole dictionary, whole data. Do is you just want to divide it into column like this. You just want to find out the tokens from the sentence. So this is first token, this is second token, this is third token, right? You want to tokenize this. Okay, so for this, for tokenize, what you are using is from nltk dot tokenize, you are using word tokenize, and you are appending it in the list. And after you do it, what you will get this as your final list. So first of all, you will win if you work hard, and then second, it will add second sentence. You will win if you work hard. Be lazy and win the life. You can see the sentence is broken into set of text. Be lazy and win the life. Now from this, you want to remove which words? Punctuation words like be, like and, like the. So these words are punctuation. You want to remove it again. So how you will do it is, so this is the list you have converted into array. Final array you get like this. You will win if you work hard. Now what you have done is you have imported the stop words. Stop words are a and the, these are the stop words. And if you use this porter stammer for stemming, what, so you have used stammer and lematizer. Stemming is uh, dividing the word, like, yes. Any doubts? Now after you apply stammer and lematizer, if you want to know in detail, you can also visit my playlist. It's on available on YouTube. Okay, so you can check that out. So stemming and lemmatization are done to remove the extra words. Okay, now after removing, what you will get is win, work hard. You can see the original sentence was you will win if you work hard. So you is deleted, will is deleted. What is remaining is win, work hard. So win, work hard, because we only require these 3 words to classify whether it's a positive sentence or a negative sentence, right? So we have converted it. Now we have generated the frequency matrix, and when we have converted it into the frequency matrix, we get values like this. Okay, so unique words, what are the unique words? If you can see from all these sentences, what are the unique words? Win, work hard, lazy. life, right? Lazy life, short. So these kind of words are there. So an array is generated, and in the first sentence, you have win, work hard. In the second sentence, you have win. So win is there. Work hard is not there in the second sentence. So work hard is not there. Lazy is there. Life is there. Right. So this is the final frequency matrix is generated. Now you have class labels. Class labels is y. If you print y, 1 0 0 0 1 1. So input is this, output is this, right? Now input is this. Actually, you have converted your sentences into matrix like this. So this is your feature vectors. First feature, second, third, fourth, fifth, sixth, seven. Seven features as input, and six training examples as input, and one output variable class y over here. Okay, this is y over here. Now what you will do is you divide the data set into training and test set. So 75-25%, and then you keep on from sklearn keras dot impose layer. So you will import a dense layer, and then activation function you can use relu or you can use tanh over here, and then you can in the final dense is the final layer. You have only one output, whether one neuron, one node. Basically it's the number of node in each layer. So this is the output. Final layer. In the final layer you have only one node, right? It is classifying as either motivational or demotivational code, 0 or 1. Okay, so there, this is the only one node is there. And then what you will do is you apply the loss function, which is binary cross entropy optimization algorithm, which can be gradient descent, stochastic gradient descent, Adam, so many other are there. Then you compile this model, you fit model.fit, and then you evaluate. So accuracy, X training, training and Y training, and then X testing and Y testing. So you check the accuracy of the model, and then your model is trained. Now you can give as input a new training example. It will predict using, it will predict for testing. Okay, it will predict the value for testing value for this. So this is how neural net time, because we are running on a time crunch. But what you can do is you can start doing it, and I will help you out with how to code with it. You can start open your collab notebooks, because last time some people said like we should be attending this we should be doing this thing more, where we can do the practical thing more. So I suggest all of you to open your collab notebooks and start working on it. I'm here to help you out and how to train this model, how to apply the collab, sorry, how to apply the how to work with the neural networks over this. So you can start doing it and you can ask anything. Any one of you who has opened the collab notebook? Or you want to ask anything like in the code, anything that is not clear, or anything that you want me to repeat or you want to understand in more detail, so that can also be done.
I have a question. You said to make a database kind of thing of 20 lines. So can you show me that like sample of the database?
Data sample. Your question is not quite clear to me. Can you say it again?
You said like there was this point to make data sample of 20 lines. So like
Mm-hmm.
can you show me that page so that I can take like what kind of examples you took to make that?
Yeah, sure, sure. This is clear. Like this is visible.
Yes.
Okay. So this is a sentence. These are the 6 example sentences. You can make more sentences like being lazy cannot uh, cannot being lazy is not for winners, or laziness. You can say life is to win. So this is a positive quote. So you can add more quotes like 20 quotes, and then life is to win. So I am using, you can see I'm using the sentences, I'm using the words which are already used like life, win, so that this matrix that is there, I don't want this matrix to be sparse, because I choose, if I choose some new words, so all these values would be zero, because these new words would not be in the previous sentences, right? I don't want to make my matrix sparse. I want as many as once, like, so I don't want to add new words over here. I want only once in below the below these columns, right? So these are the sentences. You can take a snapshot, click a snapshot of it. I hope you're done with the snapshot.
Yes, thank you so much.
Okay, no problem. And any other question? Any other
Ex-
explanation?
Can you just show the code once again?
Yeah, sure, sure. So you want me to? You can also take the snapshot of the whole code. I can keep scrolling. So, oh, so sorry. Okay, this is the starting point where I have written this code for file upload. You can either skip this part or you can directly upload it from here. So this option is also available, or I have used this for uploading. Okay, so this is the first page. Then what I have done is I have read the text file over here. Okay, pd.read csv. So you can also save this file as a csv file, file save as, and then csv, read csv. Okay, you can also read a text file using this function, read csv in pandas. I can so go to next page. You have taken a snapshot of this.
Yes, yes, move ahead.
Okay, then this is the, I have printed the data that I have taken from the this over here. So this is nothing to be remembering. Hmm. Now over here, what I've done is I converted this data into an array. So array is formed. Actually, it was copied in a list. Now I have converted into array. You can take snapshot of this as well. Done?
Yeah, yes, yes.
Okay. Then what I've done is tokenize. Tokenize means instead of using so many prints over here, what I will do is I'll delete this prints, and this is also not required, but let it be. So this is the commenting part. I've commented. Okay, I have executed this again. Now this is more clear, I guess. So first sentence, second sentence is appended, third sentence is appended, fourth is appended by in the for loop. Now this is the text to tokenize. You can take a snapshot of this as well. Third page. Done.
Yes.
Okay. Then then what I have done is I have converted again this list to an array, and I have downloaded the NLTKs of packages required for removing stop words. So this is fourth page. You can take a snapshot of it. Then let's go to fifth page. So in fifth page, this is very very important. Stop word removal and stemming. So in this is the code for converting my data to fin where I have removed the stop words. So what are the stop words? Be, I, am, in, the, a. These words are unnecessary words. So these are also called stop words. So these words are removed using this NLTK. This is the fifth page. You can take snapshot of it as well. Done. Then let's move on to sixth page, which is here. I've converted the fin. Uh, fin is the list. I've converted again into array, and then stop words are removed. You can see in the fin, win, work hard. So all the extra words are removed, right? And if you print the unique words out of it, so this unique function will give you all the unique words. So this is the sixth page. You can take a screenshot as well. This is sixth page. Then the seventh page is this one. What I have done is I have converted this text into the data frame, and I want this basically. I want this as array as this. So this is the seventh page. You can click this one as well. I want win work hard as my matrix of zeros and ones. So this is my seventh page. Done.
Yeah.
Okay. And then what I'm doing is I am creating again a list. Why list? Because I want this is motivational quote, this is demotivational quote. So this is motivational quote is 1, demotivational quote is 0, then demotivational quote is again 0, so 3 zeros. So you can see this is demotivational, demotivational, demotivate, be lazy, these three are demotivational. Then this is 1 and 1, so this means this was 1 and this one 1, this is motivational. So what I have done is I have created class labels. Okay, so this is my eighth page, I guess. Now, after 8th page, what I've done is I have divided x and y. Was my data frame, which was having 10101. You remember? And then y is my this value labels. Okay. And then what I've done is I split it into training and testing. X train, Y train, X test, Y test, split into 75% training, 25% testing. Actually, this data is very less. Only 6 sentences can never be good for training. So you need to generate at least 20-30 sentences and then train. Okay. This is your, I would say, ninth page. So this is the final code. Here I have imported Keras, TensorFlow Keras layers, and then what I have done is I have, model.fit. I have fitted the model which is sequential model. Sequential model is what you have multiple layers aligned sequentially, first layer, second layer, and then so on. Okay, so this is your ninth or 10th page maybe, and then this is the final answer where you have accuracy, X training accuracy, and then you have testing accuracy. So that's all from my side for today. Any other doubts, you can reach me out. I will share the link of my YouTube channel. You can also visit that for more details about the functions and everything. Okay, so I think that's all for today. Any questions or anything you can ask surely.
So will these Python notebook files also shared as a resource?
uh, Python coding you are asking,
Yeah,
coding
the same
assignment.
notebook, the same Python, the entire
uh,
document.
Actually, it's not advised to share it. I will ask Sabya. I have no problem in sharing. So,
Okay, if it has been shared, it will be easy for us. Otherwise, taking snapshot each time and yeah, it's good to do it from our side, but for cross checking, it will be easier.
sure, sure. So I'll share it with Sabyasachi, and then you can take it from there.
Okay, sure, sure. Thank you.
Doubts or questions or anything? I've also put the YouTube link in my slide. You can access my channel where I have put in